Okay, we should be recording, so I'm going to dive in. Anyone on Zoom, if you have questions, just turn your mic on because I'm not looking at Zoom currently, just to let you know. Okay, so starting the workflows for today, we're going to look at Voronoi structures, which is a pattern that you can create in Grasshopper pretty easily. It's one of the simplest patterns to put together, and it looks kind of cool. So we'll explore Voronois. We'll also explore attractor points and how you can affect a Voronoi structure with different attractor points. This is the first one we'll put together. So this is a 2D map. So this is the Voronoi structure. It's these cells that they're defined by a point, and they grow only as large as they need to until they meet the edge of another point. So it's kind of like finding the most optimized outline around a point that fits in a system of other points. And we'll build this together so we can see how this is moving. But just to show like what we're going to get to in the end, we'll have this script where we can move different points on the scene, and then we'll get the density and the thickness of these pipes changing as we move these points around. So we've got one point in the bottom left, and then another point in the top right, which we can move them both independently with these little sliders, and we'll see the data changing there. So that's the first one we'll put together. Yes. And then the next one is going to be, let's see. We'll look at Voronoi in 3D space after the 2D one. So this, we have a big boundary box of cells, and I've only limited the view to a certain distance around a curve. So we can have a really big curve and get a lot of cells, or we can limit that down to make this internal curve the attractor line that defines where the cells are going to exist. So, given we have enough time today, we'll try to put both of these together. They're not super long scripts. So we'll start from scratch though with the new file. So if you know how to do that, cool. If not, we can go file new and just have a blank screen. So I have a blank Grasshopper and a blank Rhino pulled up currently. Okay, so with the blank screen, we'll start by adding in a couple components. The first thing we'll do, if you remember in that 2D view, we had a big rectangle to define where this pattern was going to be. So the first thing we'll do is just define the boundaries for the entire rest of the workflow. So in order to do that, we'll start by creating just a surface in Grasshopper. So first way to do that, so I'm double clicking, and this is how I'll be working. I'll be double clicking on the canvas to pull up components. But when we pull up a component, let me just pull up one real quick. We're not going to be using this one, so don't worry. But when I pull it in, we'll be seeing the photo, the icon that's on this component, but also the name of it. So if you get confused down the line and don't know what component is what, you could double click and type in the word on top, and we can get that same component. So if you're forgetting which one is which, I have both pulled up. You're only going to be seeing either the word of the component or the icon. We can change that on the display settings. So under display, we can either toggle off draw icons, and then we just have the name of the component, or I'm going to work with the icons turned on, so we can see more of a visual workflow with a bunch of icons together, just to let you know. Okay, so the first component we're actually going to use for this is going to be a plane surface. So the second one here, plane surface, this will just give us a surface bounded by a rectangle, so an XY value that'll show up in Rhino. So we'll grab that plane surface component. So by default, as it comes in, it has some numbers already set in the component. So currently the square is 20 by 20, negative 10 to 10 for both X and Y. So we can see this one has three different inputs, P first and then X and Y. So X and Y, that's showing the how big this rectangle is going to be. So right now they're the same, negative 10 to 10. So we have those two dimensions there. P is going to be the plane it sits on. So right now, by default, it's sitting on the world XY, which if we remember from the first stage, just looking in Rhino, we have the kind of gumball like axes in the bottom left that shows us where X, Y, and Z are. So if we see X and Y, That's going to make up the plane that's shown with the grid here. And we can see by default, this is going to go on the XY, so it makes sense it's going to be right in the middle of that flat plane. We could change that if we want to put different planes in, but today I'm not going to worry about that. We're just having it centered right in the middle. So we will want to make this rectangle bigger or smaller. It's up to you what numbers you actually use, but I'm going to use a slider, a number slider, to actually change these values. So there were some number sliders in the challenge crate that I gave you last week, but you didn't have to make them yourself. They're already there. So in order to make a slider, there's a couple different ways to do it. And there are some components where you don't want to type in the name of the component to actually get the component. We could get a slider by typing it in, and we could get number slider, but there's a much more optimized way to do this. If we just get a number slider by typing it in, it's going to give us 0 to 1 with 3 decimals of freedom, which in this case, I'm going to want this box to be really big on the screen so we have a lot more space to work with, something like 100 by 100. So this normal slider is not going to do it for me. What we can do, though, instead of editing that slider, we could just type in the numbers we want to get on the slider as the slider, and it'll give us that slider. So I'm going to go from 0 to 100 for my slider. So what we can do is type in 0. So this will be the lower bound of the slider. And then we can do two periods in between. So 0, dot, dot, and then the upper bounds. So if I want a slider from 0 to 100, I can do 0, and then 2 periods, and then type in 100 as the upper bound. And we can see, let me do it one more time, 0, dot, dot, 100. And we can see right above, it's thinking it wants to be a number slider, and I'm just giving it the range as what I'm typing in. So if I hit enter on this, we'll get a number slider. And as we move it, it'll go from 0 to 100 automatically. So it's just a little bit less work than pulling out a slider from the top panel up here, editing the numbers and everything. So we can just type in what numbers we want, and it'll give us a slider for that. So I'm going to use 2 of these, one for X and one for Y. So you can either type in another slider with maybe a different range, or we can copy and paste with Command C or Control C, Control V, depending on what system you're on. So yeah, if you say you plugged a number into plane, which it's not going to like that because plane's not a number. For everyone else, what we can do is you can click on where the wire is going to, and we can hit disconnect and select the one we want to disconnect. It's one way. Or we can hold Control, and we'll get that X that comes up, and then we can just wire it backwards. Okay, actually on mine, I have a plugin up here where I can just like highlight stuff and delete it like really easily, but that's not helpful for you guys. Okay, so if we hover over now, we'll get an arrow with a little red arrow on it, and now we can just wire it backwards, and it'll take it away. So in with left click, Control left click to undo it. So if it's wrong. Okay, so as you can probably tell, we're going to use these sliders for the XY size of this plane. So we can plug those in, X and Y, and make this however big you want. I'm not going to tell you what numbers to use. We'll notice now, though, that the rectangle is no longer centered in the middle. It's now just up in the positive quadrant, so positive X, positive Y. And that's just because without these numbers in, by default, it was -10 to 10. So the boundary was going the negative direction and the positive direction to center it. But to keep it simple, we'll just use 2 positive numbers, but that's just going to push it up to the positive quadrant, which is fine. Okay, so at this point, we have a surface in the scene. So now we're going to want to put 2 points in the surface that we can use as those attractor points that are going to move around and affect the pattern. So in order to do that, there's a couple ways, but the way we're going to do it is with the multi-dimensional slider, which is that big grid I was playing with earlier to change where the point's going to be. So, okay, so in the inputs, it's going to be this one. So you could type in MD slider, or you could come to this is kind of in the way, parameters, input. So any of the inputs are going to be in this very first tab, and grab 2 of these multi-dimensional sliders. So unlike the sliders that we pulled in a second ago that can only do 1 degree of numbers, so 0 to 100, this will output two numbers, so like an XY value automatically. So we can pull this around to go from 0, 0 up to 1, 1 as an XY value. And it'll be piping both of those numbers out when we wire it in. Okay, so we're going to use two of these again. So I'm just going to copy and paste to get a second one. So just to show what it looks like coming out, what it's actually showing, we can pull up a panel. And I use panels a lot to like debug things. If I'm unsure how data is flowing, I can grab a panel and actually see what's coming out. So panel is going to be the second one that you don't have to type in panel. You could just type in 2 forward slashes. It's just a lot easier to get it, and then you can get the panel, and it'll come up with the little icon when you do that. Or you could type in panel, up to you. But with this panel, we can see it's blank by default, but if we plug in any wire to it, it's going to show us the data that's flowing through that wire. Yeah, is there a question? Cool.
Sorry, I was unmuted.
No worries. So now we can see that we have multi-dimensions in this one number. So we have an X, Y, and then the Z or 0 because there's no Z here. So when we move this around, we can see the numbers changing to align with what's looking at the point. So 0.61, 0.77, same right here, 0.61, 0.77. So that's just the data that's flowing through it, is these two numbers. So what we can do is we can use these two numbers to actually put a point on the surface itself. And working this way, it's going to be nice because the points will never leave the surface. Since we have a rectangle there, we can call the bottom left 0, 0, and then we can call the top right 1, 1. And then anywhere we put this slider, it'll move a point relative to that surface. So the way to do that, it's only one component. It's going to be evaluate surface. So this little orange dome. And for most data types, you can evaluate what's happening. So if you have a mesh, you could deconstruct it and get the different parts of the mesh. If you have a curve, you could evaluate the curve and find different data points about it. Since we have a surface, we can evaluate the surface and find out different things about it. So we'll grab that one. So the inputs here, we have surface and UV. So surface is going to be the surface we want to analyze. So in our case, it's going to be this rectangle. So we can plug that in. And then UV is just a fancy surface way of saying XY. So the reason why it's UV is because the surface might not always be flat. It could be curvy. And then we just use UV as U would be one direction, V would be the other direction on a surface. So we can use both of these points to set two different UV values to actually put a point on that surface. So what we can do is drag in one of the sliders to UV. And then if we click on this evaluate surface, we see there's a lot of outputs coming here. It's outputting a point, a normal on that location, the U and V values that it's at, and then the frames, it'll be a plane. But all we're worried about right now is the point that's coming out. So if you click on this component, we'll see in Rhino, it's going to highlight a point there. And then as we move this slider around, that point's also going to be shifting in this location. But we'll see the point is not shifting much in that location. So that's just because the MD slider goes from 0 to 1. And our surface currently, at least my surface, is 100 points long. So we'd have to change something if we want this point to go all the way to the other side. So with the MD slider, you can't really change, how big it's going. I can't really put this to 100, but one thing I can do is change the surface. So I'm not going to make the surface any different size, but what we can do, and this is the same for surfaces or curves, there's a thing called reparameterization, where you can say, this surface is 100 points long, but if I reparameterize it, I'll set the domain of that instead of 0 to 100 to now 0 to 1. So we'll get 0, 1 both directions, even though those 0, 1s are not the same distance. It's just, yeah. Yeah, if we made our surface 1 unit long, it would work, but that's pretty restrictive because you can never have a different size than that. So in order to reparameterize this to change the domain from 0 to 100 to 0 to 1, It's just one button. So we looked at this kind of last week with the flatten and graph settings with the data trees, which I'm not going to touch on, but there's another one for surfaces or curves where we can reparameterize. So this is automatically, if we right click on the surface input, come down here. If we set this, it's going to automatically reset the boundary of that to 0 to 1. So this MD slider is going to put the point anywhere on that surface. So does that make sense how to get to this button to reparameterize?
Is it right click?
Yeah, if we right click on the S input itself, so you have to be right over the letter. Yeah. Okay, so now if I highlight this evaluate surface and move this point, now we're going from corner to corner in all directions. And that point's going to be locked to this rectangle, so it's never going to leave. So I'll put this one down here a little bit. So, I mentioned last week as well that you don't only have to have one input in any input. We can put as many inputs here as we want. So that's why we have these two MD sliders. We can pipe them both into UV and we'll get 2 points independent of each other moving around this surface. So there's two ways to do it. The first way, which might make visually more sense to everyone, is to use a merge component. So if we type in merge, this will allow us to pipe in multiple inputs to a component, and then it'll just output a single piece of data. So we can see this by default has multiple inputs. So we could put the first one into 1, the second one into 2, and it's going to keep growing bigger and bigger the more inputs we put in, but we only need 2 right now. So this is one way to do it. We can put them both in this merge component and then just use the output of this merge component as a single stream. That's one way to do it, which is probably visually the easiest for everyone to follow, so we'll stick with it. The other method, if you like pressing a lot of buttons on your keyboard, is we could pipe in one of them to UV, and then if we grab the other one, we can hold shift, and we'll have a little green arrow come up while holding shift, and then we could put them both into the same component without it kicking out the first one. So it's up to you which way you want to work. I'm just going to keep going with the merge because visually it'll make more sense when you all look up at the screen. So I'll just go back to that. So 1, 2, and into there. Okay, so now we can see we have 2 points that move independently. They're both trapped to the surface. So yeah. What do you mean? Oh, not really. There are some things like if you want to organize stuff, like I could select multiple and then I could make them evenly spaced or like to one side or the other. So there's some things like that which come with Grasshopper, but yeah, if you want to lock something down, not that I know of. You can like lock in the way of disabling a component so it just doesn't work in the scene. Like if one component is taking up a lot of CPU, you could kill it, like that kind of lock, but okay. Yeah. Okay, so with these points.
Can I ask a question?
Yeah.
Sorry, I know you already mentioned this, but can you quickly go over what Reparametrize does again?
Yeah, so let's see. So yeah, say we have this rectangle that we've just drawn. It starts x at 0 and then goes to x 100. So if we have the MD slider, it's only going to go between 0 to 1, like in this area, and it can't reach the other side. So reparameterizing is just most simply taking this 0 to 1 and doing a little equation that says now it's only going to be 0 to 1. So it's the same on this axis as well. This is 0, and in my case, this is 60. But if we reparameterize it, it's going to say that now this will be 0 to 1. So instead of 0 to 60, it's now 0 to 1 in both directions. They're not the same distance. Clearly, one of them is larger. But in the sense of the point moving, every time you do the MD slider, it's going to calculate, if it's at 0.5, if my MD slider is at 0.5, that's going to translate to 50 on this axis, and it's going to put the point here. So 0.5 in this axis equals 30. So it'll put the point here. And then in between, now we have a point here on the rectangle. So does that make sense how it's working?
Yeah, a little bit. I mean, I think I'll pick it up as we do more.
Okay. Yeah, we're just doing a conversion from 0 to 1 to 0 to 100 and figure out where that new value is supposed to be. So
how do we apply that onto our plan? I think I missed that step.
oh, onto this component.
Yeah.
Yeah, so if you hover over the S input, so and then you right click on that S, we'll get a list coming up, and then you can, yep. Yeah. Cool. Okay, so now that we have these 2 points, we can use these to influence a certain area in this region that we're going to want to affect that Voronoi pattern later on. So the first thing we'll do is we'll draw 2 circles around each of these center points, and we'll call that circle like the influence that it's going to have over the density of those Voronoi cells. So with these 2 points, we can set a circle at both of those points. So if we use a circle component, so this orange circle, the orange circle is going to have 2 inputs, the location and then the radius. So we have location, we have those 2 points. So we can use the output of the points to inform where the circles are going to start. So if we plug the points into the plane input here, we'll get 2 circles. They'll be pretty small because I think by default they have a radius of 1. But we can change this radius with some more sliders. Okay, so with this, I'm going to make 2 more sliders. The range, again, can be whatever you want. I'm going to do 0 to 50 just to give me some range. So 0, ... the upper bounds to give me some range. I'll make 2 of those again because, again, we have 2 circles, so we'll need 2 sliders. And we only have 1 radius input. But as you remember, we're not just stuck to that 1 input. We can put multiple things in an input. So I can use a merge again, as we'll put both of these sliders into the radius input. So just like we did for the MD sliders in the start, we can plug the first one into the top and the second one into the second input. So now we'll be getting 2 lines of data coming out. So we can use the top one for the first circle and the bottom one for the second circle. So if we plug those into the radius input, we can start moving the sliders to actually see the circles changing. Everyone got that working? Cool, cool. Okay, so with these 2 circles, we can set each of these circles to have a different number of points. So when we go to the Voronoi pattern, the parts with more points will have more cells, the parts with less points will have less cells. So we can use these 2 circles to have their own independent number of cells. So to start out, looking forward to the Voronoi, what it'll need is it'll need points to actually map those little cells around. So in order to start getting some points, what we can do is we can set points on the initial plane and then set a different number of points inside each of these circles. So to start with the plane, we can use this component called populate geometry, this little white cloud. And this will take any piece of geometry in our sense a plane, and it'll populate that plane with however many points we want. And it'll keep those points like inside the bounds of this rectangle. Another note, I guess, when you're typing in names, you don't have to type all of populate. If it has 2 words, you can type the first couple letters, put a space, the second couple letters, just so you're not like typing out full sentences. So you can keep it pretty short. And it should do a good job, at least, of finding the ones you're probably thinking about. So populate geometry. So what we can do is it has this input for geometry. So this will be where it's going to populate points. Next one, the number of points to put. A seed value, which we'll get into a little bit. Basically, you can change the kind of randomness that's happening when it maps these points. So we'll see here, if I plug this plane into the geometry input, it'll put a random selection of points kind of evenly distributed about this grid. If we were to change the seed, it would just change how the randomness is. So we just get different random points. It's not going to matter much for this, but you could get a slider with any number of values. It's not going to matter into the seed. And every time I change this, okay, I think we need integers. Let me see. So just to show, every time I change this, we get different randomness. So it doesn't matter what the randomness is. I'm not going to use the seed today, but just to explain. And the last one, we're not going to worry about because we don't have any other pre-existing points yet. But for the number that is important, so we'll be able to change later on how many points we have in the whole scene. I'm going to go 0 to 200. Do whatever you would like. And if we plug that into the count, so the number input, as we change the slider, we'll see different amount of points coming in and out of that rectangle. Okay, so now we have the points for the original boundary, but we'll also want to set points for each of those circles. So one thing we can do is we can use the same populate geometry component, but for the circles themselves. If we were to do it right now, the circles don't have any density to them in a 2D sense. Like they're just curves currently. We'll want to make them actual surfaces to have the points populate on top of. So the easiest way to do that is to grab this black surface component. And this is just going to add a face to it. And then we should get, instead of curves coming out, surfaces. So we can see there are now like filled in circles when I click on them instead of just the curves. So now that we have surfaces, we have everything we need to populate more points on these surfaces. So, question? Yeah. Well, you can't populate 0 points. You can populate 1, but not 0. Yeah, so for some reason I'm not getting that error, but every time I teach the course, people get like different errors to me sometimes, even though this is super basic stuff like one surface, one populate. It's weird, but sometimes when I do sliders, like I'll never start at 0. I'll start at like 1 or something, just to like not have that issue come up. So you could do that.
Is Grasshopper a 0 to stuff or a 1?
Yeah, it's binary. So everything, like the first object is object 0. Yeah. Okay, so I'll need one more of these. What I could do is just copy paste this again, or if you want to type it in, you could type it in. But I'm going to grab this. So we're going to use this to populate the circles now with points. So instead of deleting the wire coming into the populate, since I copy pasted it, I can just drag the new surfaces in, and it's going to kick out whatever was in its place before. So we have the grid in there currently, but if I drag in the circles, it'll kick out the rectangle, and now we'll just have the circles coming in. And we should see more points in the circles themselves. So you could leave it with one number slider here, and it'll do 128 points in both of the circles. Or just like how we have different radii for the circle itself, we could have 2 different counts for the number of points inside. So if you want to do this, cool. If you just want to leave it with one slider, it's not going to matter. But I'm just going to drag it in while holding shift to put both sliders in. So now we can have like less points in the first one and more in the big one. And do keep in mind that the way we do like the first slider to the second slider matters. So if you follow the line, we have these 2 MD sliders. The top one controls that bottom left one I have. If I can grab it. And that's going into the first input. So when we go for the radii, the first slider is controlling the first circle. And then for the ones that I just put in now for the number, the first number controls that first circle. So that's, as we can see, that's tracking throughout all of the times we put multiple things into the same input. The first one is always going to be the first one down the line. Unless you start mixing them up, then it could be different. But now I'm keeping it all 1, 2, 1, 2, 1, 2.
So is that why merge exists? So that we can keep track of it?
It helps it. Yeah, it's a good point. So like with this one, I'm not going to know if I plug this one in first and then this one. I have no way of telling. If there was a merge though, we could see that the wires are crossing and they're up and down. So now the bottom left one is super dense. So it's also good, like if you're working, you don't want to confuse yourself to use a merge, so you can see what's going where. But just to show the two different methods, we got those both there. Okay, so at this point, we could set the Voronoi, and let's do it just to see what it's going to look like. So in order to set the Voronoi, I've said the word a million times, we can just type in Voronoi. There's a lot of different options here, but the one for 2D is going to be this like red, green, blue triangle one. So that's like the most basic flat Voronoi that we can do. So I'll grab that one. This one's got 4 inputs. So the first one is going to be all the points that it needs to construct the pattern. The second one, it's optional. I'm not going to worry about it. Third one is the boundary. So what it's going to do to contain the pattern, or else it'll kind of be infinite. So we'll get to that, but we could use the rectangle as the main boundary. And the last one, another optional one for the plane. So we don't need that currently. So what we can do is we can drag our points from the populate geometry into the input points for the Voronoi command. If we just do the first one, you see it's not referencing any of the points from the circle at all. Like it should be 1 point per cell, but here there's just a bunch in the circle. So in order for it to reference both, we'll need to put both of those point groups into the same input so it sees both of them at the same time. Again, we could either use a merge or drag them both in, but I'll pull out a merge to merge both of these point groups together. And interesting thing to note here when we do this is the top line is this smooth line, no breaks in it, but the second populate has this dotted line going from input to or output to input. It should be the same for everyone else. The reason why this is happening, and I touched on it last week, but like flat lists versus grafted lists. So if we hover over the output for the populate geometry here, we see we have these 2 folders, so 0, 0, and 0, 1. The first one has 30 points in it. The second one has 121, which matches with the sliders I put in. The first one 30, second one 121. This is just saying instead of all the points being in the same list, we have 2 lists with the 2 different circles in it. So first circle, second circle. So the dotted line is just visually telling us that we have 2 different groups here, one for the first circle, one for the second. For the Voronoi, if we plug this in as it is, it's going to be a little weird. So now we have 2 Voronoi diagrams. We have this outer one and the inner one. We can see the outer one now includes the rectangle and this first circle, but the second one, this one's by itself. It's a different diagram. And that's just because, again, we have this dotted line showing us that there's 2 different groups coming in to the Voronoi. So the Voronoi is looking at this, and it's doing a Voronoi pattern for the first group of 158 points, and then a separate one for the second group of 121 points. Which, you know, maybe you want this for whatever workflow you're doing, but for this one, we want all of the points to be within the same Voronoi diagram. So what we can do to put all of these points together is just flatten it. So take both of those groups and flatten them all into the same list. So for this Voronoi input here, we can hover over the input of points. And if we right click on this, just like the reparameterize earlier, we can come in here and instead of that, we can do flatten. And this will take anything coming in and just put it all in one list. So it'll do one Voronoi operation for everything. So now we can see that other boundary has gone away and we just have one Voronoi diagram with a single outline here. And there should not be any more overlapping lines at this point. They should all be their own separate cells around every single point. So is that working for everyone currently? Cool. Cool.
I think I still have some overlapping lines on mine.
Okay, yeah, we'll get you, Henry. So, yeah, Tina, yes? Yeah, so so I can come back in and click flatten again, it'll go away. Is this what you mean, like before and after? The flattened, yeah. So with this one, and let me break it out. You don't have to do this step, but just to visualize, like to show you. Okay, so don't worry about this step. So, okay, so if we hover over the output here, we have these two branches, so 0, 0, and 0, 1. 0, 0 has 158 points, and what this one is it's this group and then the first circle. Just because the first circle is on line 0 and all these points are also on line 0, so the 121, or what is it? My 128 got grouped together with 30 to make the first group of 158. So that's the first group. And we can see that here. This is the first group. It's taking into account the rectangle and the points here, but the points on the second circle are not referenced at all in this group. But if we look at the second branch of that, so now we're looking at 0, 1, 121 points. We can see now that we're referencing only this circle and everything else is not being looked at. That's just because we have the first set of points on its own separate thing from the second set. So it's doing one Voronoi diagram for the first set, a second separate one for the second set. So those are data on two different branches. But the nice thing about Grasshopper, which can also be the confusing part, is we can put a bunch of branches in this one wire here. So we can work with a lot of different things at one time. But for this workflow, we want to see a single Voronoi pattern. So we don't want these two separate patterns. So we can take the 158 points and the 121 points and just put them into like the same group. So take them out of their separate groups and put them into the same one. And we can do that by flattening. So has anyone worked in Photoshop in here? Like if you have multiple layers and you flatten them, and like it's one thing. We're doing the same thing. We're just taking like two separate lists of data and flattening them into the same list. Okay, cool. So yes, so now if we look at it, we see the two different sets. So Henry, did that also help you at all? Or is there still an issue?
Sorry, I think there's still an issue with mine. I can't figure out how to get rid of the overlapping structure.
Okay, do you want to share your screen?
Yeah, sure. How do I share my screen?
Let me, actually, you try it. It might just overwrite mine.
Oh, it says you disabled it.
Okay, then let me stop this one. Okay, try it now.
You got that?
Yep.
Okay.
Cool.
What am I missing here?
Okay, so zoom into that Voronoi in Grasshopper.
Oh, the Voronoi.
Yeah, over to the right. Yeah.
Can't move around.
Yeah. So we have that dotted line going from merge to Voronoi.
Yeah.
So it's not a smooth line. So we have two separate lists coming in. So
Okay.
we'll just flatten the list. So you could either hover over the R output of the merge or the points input on the Voronoi. Either one, if you right click on it and then go to flatten, then you should have a single pattern, which it looks like it's good.
Wow. Okay, yeah. I just flattened the wrong thing. All right, cool.
Yeah, if you ever have a problem in Grasshopper, like when anyone's ever learning Grasshopper, they're always like, "Oh, I didn't know what was happening, so I just flattened it and then it worked." Like it's usually a thing that'll happen. If you don't know what's going on, either graft it or flatten it and something will change, which might be what you want.
Cool.
So good to know. Cool. So I'm going to share my screen again. Okay, cool. Okay, so at this point, we have the Voronoi pattern. But let me find, okay. So it's technically working, but we can see there's some areas where there's 2 points that are very, very, very close together. It's not breaking the Voronoi pattern, but I don't like the points being this close together. It'd be nice if they were more evenly spaced out, so we have a more even size of cells instead of one cell being like really small next to another really small cell. So what we can do is we'll put a component in between the points and the Voronoi to solve this issue. So what we can do is we can use a component that'll look for any points that are like way too close together and just delete one of them. So we're left with like a more even list of points. So this is just one component. It's called cull duplicates. Does anyone know what cull means? C-U-L-L? Yeah, in like mathematical terms, it's just like delete. So this will delete any duplicates. So cull duplicates. So bring that in. And we can see on the bottom here, it's saying average. There's a couple different options if we right click, which doesn't matter, but just to show, we could leave one of the points, we could delete both of them, or we could just find the average point in between. So we'll just leave it on average, not to make it more complex. But at this point, we can drag all of those points into the point input for the cull. And again, to make sure it's looking at both lists of points to delete from, we'll have to flatten this one as well. Cull points, PT, yeah. Yeah, there's a couple different cull options here, so. Oh, sorry, yes, duplicates. It's a little confusing with the name it has there, yeah. I don't know what this abbreviation is then. It's quite weird. Huh. You can stretch it, yeah. Okay, so there's two inputs, points and the tolerance. So the tolerance is going to be the distance it's looking for to either delete one or not. By default, it's 0.1, which I feel like is going to be fine for this. If we need to change it, we can. But now if we replace this wire with the new cold list, let's find some close ones. Okay, it didn't look like any of them were too close together, so just to bump it up to show you. Okay, so we can see now I had to bump up my tolerance from 0.1 or 0.01, whatever it was, to 1. Now we can see some of the points that are a little bit too close together have been replaced by a new point in between. So that's just kind of cleaning up the structure a tiny bit. So yeah, you could use a slider. You could do a slider with one, or you could have a panel. So you could, what I did was you can do 2 forward slashes, or you can type in panel. And with that, you can double click and you can set data in there. So I can just set the number 1 in there. The difference between like panels and sliders is a panel, it's kind of set. It's a little bit harder to change the value in there. The slider, you can really easily pull it around. So up to you which one you want to use, but it's not necessary to put in this one, but just to visualize on my screen what it is doing is now I have 2 points that are within 1 millimeter away from each other. So it found those and it put a point in between. So with this, we can replace what's coming into the Voronoi currently with this new list. So I'll just replace it. And we'll see now those cells that were bifurcated, the ones that were like a little bit too small are now just a little bit more even, just for the looks of it. Okay, so is that working for everyone else currently? Got that working? Okay. At this point, we've made a good amount of components and they're all showing us what they're doing in Rhino. So now it's getting to the point where it's a little bit confusing. There's multiple point systems overlapping. So what I'm going to do is just hover over everything that's not that last component. So like select everything except the last one. And we can right click off to the side on the canvas and just turn off the preview for everything that's not the most recent component. Just so all the data that we don't need anymore is like hidden from our view. So we can just preview off. And now we're left with just that Voronoi structure on the screen. Just make it a little bit easier to see. Okay, at this point, yeah, we have a good Voronoi pattern. We should have a good Voronoi pattern. One thing though, we can see the pattern is extending arbitrarily out to this really big bound, which is bigger than the rectangle that we had set. But if you remember some of the inputs from the Voronoi, there's another input here called boundary. So we can actually set the bounds of the whole pattern, which is this B input. And this, it's looking for a rectangle parameter. So we have that rectangle from earlier. We have this surface. We can plug in, and this is kind of optional, but it's nice to have. We can plug in this surface into the boundary input, so that uppercase B, and then you'll see it'll crop it just to that rectangle, so we don't have excess pattern. Okay, so at this point we have the 2D pattern, and we can come back and we can start moving around some points, and we'll see the pattern will automatically update. And that cold duplicate's just going to help if on the edge case chance that there's points that are like insanely close together that the Voronoi fails completely, that cold duplicates will help us clean up the data before going to the Voronoi, so we can change this as much as we want, and we won't have any weird issues happening as we move these points around. Yeah, so we can change, again, the size of the circles to affect the pattern, and then, also the density. All of this is still live. So we can come back and change this whenever we want, and it'll update the final Voronoi structure. So I'm going to drop all my numbers down really low. Well, for the next things I'm going to do, I might crash Grasshopper if I have a bunch of stuff. But we'll see. Okay, so at this point, we've gotten like half of the final thing. Question? Yeah.
I have just the one circle working, so the
Yeah.
one circle is up here.
Oh, wait, what did you disable?
Well, I was thinking everything except the last that we added.
Like, okay, did you?
It's like a Garia.
Did you preview off or disable it off? Okay, is it like grayed out, like the component?
I disabled it. Yeah.
Okay.
So disable just like turn it off. You just wanna. Okay, and then is your size or density? Oh. Oh.
Hell yeah. Okay. I believe so. Everyone's let's keep them hidden back there. So next week.
Right, fine.
Okay.
You just want to get rid of.
So we good? Cool. Yeah. Okay, so at this point we have the 2D structure, but the one I showed you earlier, it was 3D, and then we were controlling the diameter of all the pipes based on the points as well. So this will get into like even more ways you can use attractor points to affect other things down the line. So the pipe component, which we'll end up using, did you plug in pipes to the curves?
Yep.
Okay. So if you waited like 2 seconds, so the pipe, yeah, it'll work at some point. The pipe component that comes with Grasshopper is very not optimized. If you plug in a bunch of curves, it's going to take forever to calculate. So I turned all my sliders down a lot. The workflow that I have pulled up on my screen, I have a plugin that's will do pipes a lot better than the standard pipe component. We'll get into plugins at the end of today's class for the future. But for today, I'll use the pipe component. But I turned down my numbers, so I have very few curves. I have 65 curves. So I hope it doesn't break. Let's go even lower just to see. Okay, we have like no pattern anymore.
Oh, here. It didn't even press.
Oh, it just went away.
Yeah.
Okay, so I did the pipes on a very, very low resolution. You can see it still took 2.8 seconds to do this though, which is pretty abysmal. Yeah, if you want to turn on how fast it is, again, if we go to display and then canvas widgets, you can turn on the profiler, which will tell you time based. Yeah. Okay, so maybe we'll do plugins now and I'll give you the better one because that'll solve a lot of issues. So just delete that pipe component as quick as possible. Just delete that one. Yeah, don't like that. Okay, so in Discord, I have oops. Okay, so I'll go to file sharing. So I have this this zip file. Does everyone know how to unzip files and stuff? Yeah. Okay, cool. So let me put this in. So this zip file has the plugins for the next 2 classes. So stuff for today and stuff for next class. I'll give you some more in the future, but I'll put that in here. So normally when you're installing plugins, you have to go to a website, make an account, download a file, unblock it from your computer so it doesn't think it's a virus, and then install it. I did all of those steps for you, so you just have the basic stuff here, just to make everything more streamlined. But just to know, if you were to add your own plugins by yourself in the future, there's a bunch of steps to go through. It's pretty detailed online, but also if you have questions, just put it in the Discord. I also have a YouTube video I made that like tells you how to install stuff and unblock and download and all that. But for today, if you get that zip file and unzip it, we'll just use what's in there. And let me actually open that up. Is it taking a while to unzip it? Okay.
Mine's saying I don't have it.
I mean, yeah, we're not going to be opening anything I gave you. Like, yeah, don't double click on it. It's not going to do anything. Okay, so if you've unzipped or extracted the file, we should see plugins in here. The only one we want to look at today is going to be this MV one. So there's some stuff in here, but don't worry about it. We're just going to drag and drop some things in a second. Okay, so is this Mesh Plus? Oh, wait. Okay, I lied. We don't need any of those today. We'll go over it at the end of class, but we still do need a plugin today. I forgot it's different though. Every plugin has different stuff. In Rhino, we have the command line where we can type in commands. We can type in a command called Package Manager. This first one here. Package Manager should pull up another window. I'll leave this up for a second. So Package Manager, pull that up. Should be another window. Hit enter. Okay. Oh, fuck.
Mine doesn't have that.
Are you both on Mac? Okay. The plugin I'm pulling up is not going to work for Mac. The only ones that will work, I think, are Pufferfish.
Your school highlighting.
Thank you.
That's so funny.
Okay, I can yeah, that one's nice. Yeah, if you're just on Mac, it'll be tough running the rest of the semester without some of the plugins because a lot of them are like actually part of the definition. Yeah, so if you look into boot camps or partition type things, you could just do like a small partition too. It doesn't have to be massive, but just to run Rhino. Okay, so, and you can still use the pipe component for this. Just keep the lines low for today's thing. but I'm going to bump the lines up once I get this one installed for you guys. But the plugin, if you type in n gone, we'll get this one picture coming out, should be n gone. And this one, I guess it's easier to do it this way than the whole download process, but if everything's different, it doesn't really matter because you still have to do everything. But for Ngon, at least, we can type it in here. You should be able to click it and then install it straight into Grasshopper, so you don't have to drag and drop anything or unblock. Yeah, you have to save your Grasshopper file. Good to note there. The Grasshopper is different than Rhino. They're two separate files. We won't have to save Rhino because we don't actually have anything in Rhino, technically. It's just only in Grasshopper. So yeah, install it, save the Grasshopper to your computer, and then we'll just restart real quick and pull this back up.
Okay, does Grasshopper just like Rhino?
Yeah, so there's not anything technically in Rhino right now. We could close the Rhino and we're not losing anything, but if you close the Grasshopper without saving, then you'll lose that. But yeah, everything is just like showing up in Rhino. So hopefully it restarts quick for you guys because you don't have a lot of plugins yet. Mine, if you were here last week, it took like 10 minutes to start for some reason. Get a little break, I guess. Is there a chat? What is this? Oh, Grayson, you have package manager. Okay. Do you know what Rhino type you have, Grayson? Is it like 6 or 7? I don't think it'd be different, but
yeah, I think 6 doesn't.
Okay. So you can still download this tool. I think you just have to get a different one. Okay, so for Grayson, I'll go through the plugin part, but if you actually want to get this one,
We get the Discord presence for you.
Sure.
Send your file into
install everything. There's a website called foodforrhino.com, which I think we've looked at before, I forget. But in here, we can download all the plugins that we'll need for Grasshopper. Most of them are all in this website, and we can look for them here. So we can look up Ngon, and we'll find that one, this little bunny. So in order to download, you'll have to be logged in with an account, which might be linked to your Rhino. I'm not too sure. You might have to create a new one. But once you log in, we can come down to download. I'll just log in quick. Okay, so we'll see that for 3.2, which is the most updated one. There's the install button, but you can get 3.1. It's got all the same stuff except for some updates, but it should have the one component we need. And then you can download this and install it like you would any other plugin. You could also try to hit install and it might open up your Rhino, but not exactly sure. But let me know if one of those works. Okay, cool. So I'll let you install that yourself if you already know how to do it. But yeah, that should be what you have to do. Okay, so has everyone restarted Rhino? Are we still? Yeah. Oh yeah. Grayson, if you need the file, if you need the file I have pulled up currently, I can just give you the file so you can just open up the Grasshopper. It'll take you a while to like copy it by hand. Um, okay, so everyone else, are we back to this point in Grasshopper? Okay, cool. Okay, so now if you have that installed and restarted, we should be able to type in mesh pipe. Should be this gray one. And instead of doing a pipe as a B rep as what Grasshopper was doing earlier, now we can do a pipe with just like 3 faces around it. So it's a lot simpler of a geometry than the pipe component that Grasshopper comes with. So I'll grab this mesh pipe, plug in my points. And in this case, it's not even taking a millisecond. Like there's no time down here. So it's a lot quicker than the pipe component. So just to see what it looks like, because right now the radius is 0.1, which is super small. So I'm just going to grab another slider, whatever size you want. So now we can see the pipe is changing as I change the slider. So doing it this way, we don't have any control over the radius of the pipe in relation to how close it is to those attractor points. But this is just a good way to visualize like it's working. We can see it's making a radius, which is pretty nice. So I'm not gonna use this radius in the end. We're gonna construct another way to control the radius for each specific curve based on the distance from the attractor points. And a lot of these workflows, you can use these for a lot of different projects as well. Anything that needs like a point manipulating another piece of geometry in Grasshopper, we can do a similar workflow to this. So okay, so let me make this a little bit smaller. So let's see. Okay, so thinking back to the beginning, with this evaluate surface, it's giving us the 2 attractor points, which we can use to affect if a pipe is farther away, we can make it a lot thicker. If it's really close to the point, we can make it super skinny. So we're just going to do that for all of the curves at once. So we can use these 2 points as the attractor points. And then we can measure the distance between the points in the entire system. So everything coming out of the coal points, we can measure the distance between these points and the attractor points. And then based on that value, we can set the radius of the curve in that set. So there's one component to do this, to find the distance from point to point, is this component called closest point. So just the singular version of this, closest point, not the plural, not the points, just the singular point. So we'll do point to point measurements. Yeah, so if you right click on any slider, there's a button for edit. So you can hit edit, and then it should pull up a big panel with a lot of different options. So you can actually change, like if you don't want 0 to 1, you can do 0 to 100. Yeah. Okay. Yeah, and then you can update the min-max range. Just by double clicking, you could set like 100.
No, I only want it. I want it to be like 0.2.
0.2? Okay, yeah. So
but it will only let me go 0 to 1 on this.
Yeah, so by default, if you typed in, like if you started like 0 to 1, then it's only going to do integers always. If you want to go to a float value, so like a decimal point, in this view, right now it's selected as integer, but you can just hit real or floating point, and then we'll get those, and then you can do whatever you want. So yeah. Cool. Okay, so closest point, we got this component out. What this one's looking for is it's looking for a point to search from, and then a cloud of points to search to. So we have like starting and ending to do our measurement. So with the point to search from, we'll start at the cloud of points themselves. So we'll start the measurement here, and then we'll find the closest point to these, and then find the distance from that. The only reason we're not just doing a measurement from every point to the 2 points, like we could make it super simple and just find a distance from A to B. But this is going to find, if we have a set of all these points, and then we have 2 attractors, say these little circles are the attractors. If we just do a distance from everything to the attractors, we're going to see like a point set like this, where everything is going to everything else. Which now we have 2 distances for every point, which we don't want 2 different distances for every point. Let's see. So if we find the closest point, what this is going to do, if I have a list of points again, and 2 attractors, this is going to find, if we start out here, it's going to find the closest point in the second set to it. So these would find this point, and these 2 are going to find this point. Now we only have 1 distance value, whatever this is, 0.5, from starting to finishing, only looking at the closest point to that other one. So we'll be left with a single distance value, even though we have 2 separate attractor points. So that's what the closest point algorithm component is going to do. So we can take the points from the goal point into the first input. So the points to start the search from. And then the cloud of points is the points we're going to be looking at. So just those 2 attractor points are going to be the cloud. And out of those 2, it'll find like which of those 2 is closest to any other point in the larger list. So we can take the 2 points coming out of the evaluate surface, the 2 points here, and those will go into C. So that's the cloud. And it's not going to show up as anything, but to visualize it, we can see what this is doing compared to just a brute force like measurement between 2 points. You don't have to do this step, but to visualize for y'all, if we look at the points from the whole group and then what points they found, we can see that we have the points finding just the closest one of that other list. And you see as I move it, those points are only finding themselves. And if we get really close together, now we have like a division between the 2. If I go farther away, now they're completely separate. But we can see this is different than doing, let's see, than all points to all points, where we have more of a messy group of them. So closest point it keeps everything separated. So we can see this one attractor point is only affecting the data immediately around it. The other one is just going to do the data around that one. Okay. Okay, so back to your attractor point, we have a couple outputs here. The one we're interested in is going to be the distance. So that's going to be the distance between the values in P and the values in C for those inputs. So now we can see the distance, like each of those green lines, we can find the distance of those from this one distance value. Oh, I don't want to delete both. Okay, so with the distance, it's arbitrary values of distance, 16, 14, 15, which they would work as radius values if we pipe them straight in to here. But it's not really useful for this because 15 is just arbitrarily a big number. But what we can do is, similar to reparameterizing the surface, we can remap the domain of the numbers. So we could take this first value of 16 and say we want to remap it between 0 and 1. So if 20 is our largest value, if we put in a value of 16, it's going to be like 0.8 or something. So we'll script that out so we can see what remapping will do. So first thing to do is actually to get a remap component. So this will take an input set of numbers and a domain, and it'll do some math to refit a certain set of numbers to a new, smaller or bigger set of numbers. So right now, all of the radii are way too big. So what we can do is set a new domain, a much smaller domain, and it'll remap the numbers from distance to this new set that'll be a lot smaller, but still keeping like the same organization of it. We'll see how this does in a second. So to start, it has a couple inputs. The first one being values to remap. So we'll want to remap the distance values into a new, smaller set of values. So we can plug the D into B here. And then the next two are import. So the first one is the source domain. So this will be the smallest and largest values in the distance. So I don't really know what those are. It's kind of hard to see in this list, what's the smallest value out of 26 points, what's the largest. I'm not going to do it by eye. We can let the computer do it. So there's another component called bounds. And this component will take any list of data and it'll find the smallest point in that and then the largest number in that. So this will be nice to set up our start domain or the source domain. So we can plug in our list of distances to the boundaries or to bounding domain. And then all this is going to do is it'll convert it into two numbers, so small and large. So it looks like the smallest number was 2.7 and the largest in my list was 17.9. So instead of a source domain of 0 to 1, we can use this as the source domain. So what this amount of data, what domain that is in. So we can remap that to a new domain. So this one, it's going from 2 to almost 18. And we can see 18 is massive. We don't want that. It's not looking good. So we can construct a new domain a lot smaller. So to start, we'll need two sliders or two panels, whatever you want to do. I'm going to use sliders. Looks like we'll go between, in this case, I'm going to put in a decimal to start. So I'm going to do 0.1. And this is important because, as Sean mentioned earlier, if you start a slider with just integers like 0 to 100, then you can only slide from 1 to 2 to 3. If I start with the decimals, those say 0.1 to 2. Now when I slide, I can go from 0.1 to 0.2, 0.3, 0.4, up to 2. So we have more detail of decimals in between the integer 0, 1 to 2. So I'm going to grab two of these. Is that making sense for people? Is that you getting that decimal slider instead of an integer slider? Cool. Okay, so with these two, we can set the lower bounds and then the upper bounds. We're not going to see what this will do until we actually plug the new radius values in. But to start, we'll make the upper one smaller than the lower one. And with these, we can actually construct a domain out of these. So the component here would be construct domain. So it tracks. So this will take our lower and upper and just construct it into a domain that the remap component can read. So we can plug the top one into A, bottom one into B. If we hover over the output, now we see we have a domain from 0.5 to 1.5. So it just added that 2 in between the two numbers. Okay, so now if we take the domain that we constructed and put that into the target domain, now it'll actually start doing the math and taking our original distance values and converting them into a new set of smaller values. Plug that in. So, okay, now if we replace what's going into the radius currently with our new set of numbers, okay, now the radius is, the radii of all the curves are a lot smaller. Now I'm just going to add, in my sense, because I'm using mesh pipe, I'm going to go back and add some more numbers here so we can see a little bit more how this is reacting. There we go. And I might turn off some points again so we can see this a little bit better. Turn this off. Okay, is that working for everyone? Is that making sense what we're doing? Question?
But the VMAP, that's you have just the value in this, just the
yeah.
Yeah, one that that's what I.
Like you just
this is so. This is take the bounds the domain that's already in. Make that the bounds for the map,
Yeah, so these two sliders are now our new bounds. So like if I have a distance, like my smallest distance was 1.87. So instead of having like wherever that is, it's probably one of these or something. Instead of having the radius be 1.87, now it's going to be 0.2. So now this is 0.2 instead of
so we're taking the pretty large domain of the distances, just setting it those distances to be like a smaller range, so that we can increase the distance if it's still range of like 2 seconds.
Yeah, no, that's a good point too. So like, if we move this point farther away from everything, the largest pipe we're ever going to get is only going to be 2 as the radius. So it doesn't matter how far away it is. Right. Yeah, so this is what we started with the original distance values, which are arbitrary to what we're doing with pipes. And then like if I was to look at just the first pipe of each set. Okay, so this is the first one originally, and this is the first one after we remapped it. So we can see whatever radius it was, which we can actually see it was 16, but now it's 0.8. So 16.8, as it just does that math in itself. So yeah, very, very similar to the reparameterize we looked at earlier, where we had a distance from 0 to 100, now it's 0 to 1. So if we go to 50, it's going to be 0.5. So just doing that simple like ratio math to figure it out.
Bounds, it says this component 9 once, and then it doesn't show it. Yeah, me too. I cannot see the numbers.
Okay, yeah, let me walk around. So it says it right once. And it's not what?
Like it doesn't change the
Oh, as you change the slider.
No, as I change the slider, it changes, but like like the thickness of the radius, it doesn't change that.
Okay.
Maybe it does. Okay. I guess yeah, it does. It does. I was just.
Oh yeah, it could be so slight. The difference in the radius.
Oh, because do I have?
Yeah, you could push the top one all the way down to the left, the bottom one all the way to the right.
Oh, okay, gotcha. Okay. Did this, okay, and then where's this, like,
the component that doesn't really matter right now. Okay. Yeah, every time you change something like farther left, it'll redo everything to the right. So if you change where the point is, it'll run everything once again.
Okay.
But for most components, it's never going to run multiple times. There's very rare components that right a lot of stuff, but usually it's going to run everything once every single time it changes.
So and it doesn't matter that it's like not showing around. Yeah, it wasn't showing you the value before.
Yeah, so it's very specific.
Hover over the eye.
Yeah, so if you hover over the output, it'll show you something. If you hover over the name, it'll show you something
That's
different.
what I was
If you hover over the input, it'll show you something different.
Perfect.
Yeah. So there's like a hidden UI in here where you hover over different very different areas.
That's okay. I had the same problem. I just didn't know the mouse. Okay, so in order to
Yeah, I want to ask a question.
Yeah.
Are your joints also like not connected?
Yeah, like this one.
Yeah. Okay. I just want to make sure like that's.
I'll take it.
You bring up a good point. So there's a couple things we can do with these like open ends here. So this is going to be the same no matter if you're working with the pipe component or the mesh pipe component, but it has this input called ends here. Right now it's by default it's 0, but we can see 0 is no end. We could do a box, dome, or flat. I like the dome one, it'll round off everything. So if we give it, so we can see it's telling us what it needs. 0 would be nothing, 2 would be a dome. So if we input a 2, it'll give us a rounded end cap. So we can plug in a value of 2, and we can get little round circles at the end. So that helps cap it off visually. That's one way. Let's see. Another way we could do, instead of doing this end cap thing, is we could affect the line itself. So if we look at what's coming out of the Voronoi, we have polyline curves. So a polyline curve is going to be a lot of line segments. It's not a smooth curve. It's a lot of broken segments. So that's why we're seeing this broken segment look, especially in like this one where it's rounding around a circle. So what we could do to change this is to actually take these polyline curves and turn them into smooth curves. So two components to do that. The first one would be rebuild curve. And this one, we can set a different number of control points to help round it out. So if we plug in curve, we can also plug in a slider, arbitrary numbers. But as I do this, we can see the curve start to change. So the less number of control points we do, the more jagged it'll be. The more we do, the more smooth it'll be. I'm just going to go for about 10 or so. And then with it like this, we have the start of a smooth curve. We can smooth it even more with smooth polyline. And then this top input here is going to be the polyline 2 smooth. So if we pass that data over, we'll get an even smoother curve. And then we can use this new smooth curve instead of the Voronoi pattern. We can change out those inputs. And now let's keep this end cap. Now we can get like a smoother, like curvier pattern is one. And we can go a step farther. And it's technically still a polyline. We could, and this is all optional, but we could find all of the points of these curves and then construct a different type of curve. So we could do an interpolated curve, which is always going to be very smooth. Let's see if we just preview this on. Compared to the polyline, this has infinite smoothness around. It's still open at the end, so one thing we could do is change the periodic nature of it. This has a true-false value, so we can use a toggle to switch it. Again, this is optional. But if I set this to true, it'll end off those curves. And then if we re-plug it in again, it might crash. So maybe just stick with the polyline. I forget, these different pipe options like have different things they want. I think the mesh pipe only wants polylines. It's maybe why I didn't do an interpolated curve before, but just to show different ways to affect curve, we can do a very smooth curve like this. Okay, so that was the workflow for the 2D. Before we end off class, what? Oh, it was a toggle. If you type in toggle, you get a true false value. But just take my word of advice. Don't plug it into the mesh pipe because Grasshopper is not going to come back. That's for sure. But it's okay because we're going to move into installing plugins now to end off class, so we know how to do that for next class. You installed some plugins? Oh, it actually came back to you? Yeah. Well, I don't know. It didn't fail. Okay, it might come back. How many lines did you have though? Oh, it came back. Nice. Okay, cool. It looks really smooth, but it took a minute to calculate. So yeah, don't do that. Okay. So this is smooth enough. Yeah. Oh, it'll still do it. It'll just be like open at the end. So, okay. So that's working for everyone today? This thing worked out? Cool. I go around and move stuff around. Very fun pattern. Oh.
RJ.
What's up, Henry?
Are you gonna put this Grasshopper file like in the shared file so we can kind of look over our work?
Yeah. I'll put it in right now, actually. I'll save this again.
Okay,
Update.
appreciate it.
Yeah.
Oh, you already did that. Cool.
Well, it's from earlier today. It's like half of the script. So this is now the full one.
Gotcha. Okay, because I feel like there's like, yeah, I definitely missed something.
This is just a work in progress build. So just take that one.
Sweet.
Yeah. Okay, so for the next 10 or so minutes, we'll just look at installing the plugins I gave you in that zip file earlier. So should be these ones. So we have a couple here. The first one, which is just a single file, is the shortest walk, which we'll use next class. Or no, maybe the class after that. But next class, we'll use Pufferfish, which is one plugin, and then Mesh Plus, which is this other plugin. They each have their own fun things to do with the workflows. So let's look at Pufferfish just because it has more stuff going on with it. Okay, so you'll notice we have this one green component that ends in GHA. And then we also have these .gh user ones that are orange. So green, orange, look at. And then you notice the ones in Mesh Plus are also orange. So the green versus orange, they're two different kinds of files for the plugin, and they go in two different places in Grasshopper. So with Grasshopper open, if you're installing file plugins that you downloaded, you can come to File, Special Folders, and then we have these two special folders, Components and User Objects. Components are going to be for any of the green files. So I'll open that one up. And we'll see, I have a bunch here. I should already have Pufferfish installed, so yeah, I have it here. So it has that green file in it. Okay, so that's the first, which was the first one? Yeah. Okay, so that's components. So with the components folder open, we can drag any green files into there. And again, if you're doing this yourself, you have to make sure they're unblocked before you do this, which would be right-clicking, going to properties, and then making sure there's not like a block button, which I already did that step for everyone. So you should just be able to take the green file, so pufferfish.gha, the green one, and drag that straight into the components folder that you also had open. So I just drag that one over. Yeah. Okay. Let's see. So it's that one. Okay. So I have this window open. This is the zip file I gave you. So you should have unzipped this one. We can go into Pufferfish. We can see the green Pufferfish file. Cool. Yep. So in Grasshopper, File, Special Folders. And then Components. And then open that one up. We should have another File Explorer window. Yeah. So I'll drag that one to the right, and then I'll pull up my Pufferfish folder. And then we can either copy paste or drag this green file straight over to the components folder and just drop it there. Cool. That's good to go. And then once you've done that for all the green ones, you can close out the component folder. We'll come back to File, Special Folders, and now we'll open up the user object one. So this is going to be for all the orange file types. So I'll open up user object. So I have user object on the right, my pufferfish plugin on the left. And then we can, two things, if you want to keep it organized, we can drag the whole components folder straight in. But we'll want to make sure inside it's only orange file types. So that looks good to me. So you can drag this whole folder into the user object panel, drop it in there, good to go. We'll do that for any plugin that I give you. So you'll want to make sure one or the other, green versus the orange ones. For Mesh Plus, they're all this orange type. So you can just drag all those straight into user object. You can put it in a folder if you want to keep it organized.
Folder name is?
It doesn't, no. It doesn't matter how you organize your files in the special folders at all. Grasshopper just cares that the file is in there somewhere, and it'll just load them all at the very beginning when you open up Grasshopper. For the orange ones?
Yeah.
Yeah, so those in Grasshopper, if we do file, special folder, and then user object, this is where all the orange ones will go. Yeah, and that'll just go in the component by itself. Yeah.
Oh, wait. What are user object?
Since it's green, it goes in the component folder. Yeah.
But I still have no user object.
No. Yeah. The pufferfish is one of the ones that has both. Most of them, though, it's either going to be like a single green file or some orange files. But yeah, pufferfish is one of the rare ones that has like a lot of both. So, yeah, I mean, you can see my components folder. There's some folders, but there's also just a lot by themselves at the bottom. So, yeah, basically it takes curves, and then it takes like a set of curves and just makes a pipe around all of them. It's like a piping tool, but they're not going to be separate. It's going to be like one solid pipe 3D body thing. Yeah, you could. I can. I forget what it's called. Oh yeah, in here, just fatten. So it takes a skeleton list, which is just curves, and then yeah, it just puts a body around everything. So
instead of having to make a bunch of meshes, it's like one.
Yeah, so like where the mesh pipe is, let me turn this down so you can see. This one's a bunch of different curves. You can see like all the disconnections. And this is just going to be one solid thing. And if somehow you like combined all these curves into one big curve thing instead of like separate circles, it'd be even more solid. So that's a nice single component thing. A lot of these that are singles that were like coded in 2012 or something like that's super old. The skeleton fatter one is super old, but it still works pretty well for some things. So, but yeah, those are all like ways to make mesh pipes. What do you think? You want this bar up here? Yeah. I can show you. It is a nice one to have.
Yeah, but I wish I like click on a line and delete it.
Yeah. Well, let's get that one then because it's a nice one to have. Which you might. I mean, I can just give it to you, I guess. So you don't have to all make separate accounts. But yeah, food for Rhino, this top one here, everyone loves it. Pod GH button. Yeah. Yeah, download it if you can. Anyone not download it? Because you have to log in to get it, so it might be a little bit. So I'll download this one for you and give it to you. Yeah, which one to get? Just do the one that has the most recent date on it. So 8/30. Yeah, the bottom one, yeah. Okay, so just when you first download something, it'll come to your downloads. This one is only a single file, so you'd click on it and you'll want to follow. unless you know how to do it. So you'd right click, go to properties, and in this one we'll see an unblock button just to unblock it for our computer. Hit apply, okay. Now we're good to install it. So back here, and at this point, I'll give this all to you so you can follow from this point on. Okay, so download this file. Right, I already did it for you. So, and everyone knows how to put it into the components folder. It's just one file this time. So let me know when you get it back up, and I'll show you like the good tips for it. I only use a couple of the buttons here, but there's a lot of cool stuff in this one.
You have to restart right now.
Yeah. It should either be in the canvas or between the little pen, like up in that bar. Do you got it to on? Huh? You got it to come on?
Yeah, I have a word. Mine isn't like up and down like yours, but it's like
up
to the eyeball.
Yeah, that's how it is on my PC. So and Sean, did you download it yourself?
Yeah.
Okay, maybe check to make sure it's unblocked in the one I gave you. You can just open up your component folder and check it from there. Okay. So everyone go and unblock it yourself. I don't know why I didn't transfer it.
Like Windows would just automatically not unblock it. That wouldn't carry over.
Yeah, I don't know. Like, because I did it on mine, so I guess when I gave it to you, it wanted you to do it again. Weird. Okay. Good to know. You figuring it out.
Oh yeah.
Yeah, so this one, some of my favorite buttons, the cursor with the X on it, that's the one I always have on. So if you left click to enable that one, you can just hold control and just box over wires and it'll like auto delete the wire for you.
Do it for components.
Just the wires around it. Yeah. So that one's nice. The one right to the right of it, you can turn it on so you don't have to hold down the cursor every time. So say you have a really big file, I can just click and like not hold and it's still selected. So I could drag it and go plug it in somewhere else without having to like hold it, move the screen, plug it in, whole thing. So that's cool to have. The other one I really like though is, say I'm modeling something in Rhino, like I have this box I made, and then I'm gonna add this to Grasshopper as a B-rep. So I'd select it, set it as a B-rep. So now it's in here and I want to start like modeling something with it. Maybe I'm populating this region with points. But the box in Rhino is still there, like obstructing my view of what I'm doing inside of it. So this one light bulb one up here, if you left click it, it'll hide anything referenced in Grasshopper. So it's referenced with this one, so it's hidden in Rhino. So now we can see what we're doing inside of it. So I don't have to go change the layer and then hide it with the layer button. You can just do it right from there. And then if I right click, it'll bring it back so I can see it again. So that one's pretty nice. If you have a lot of objects in Rhino and then you use those in Grasshopper, this will just hide all of them for you. So nice to have these sorts of things to work quicker. That's about it. It's 6:56, unless you have questions. That's all good. I do have another challenge crate with Voronoi stuff, which I'll shove in the Discord later. So
Thank you.
welcome.
Thanks, RJ.
Welcome.